Hi everyone, today I'll be talking about how to solve quadratic inequality. But what's a quadratic inequality? A quadratic inequality is similar to a quadratic equation. We all know that a quadratic equation is of the form ax squared plus bx plus c equal to 0. Example of quadratic equation is x squared minus 3x minus 4 equal to 0. A quadratic inequality is similar, except that instead of equal sign, we have greater than sign, or greater than or equal sign, or less than sign, or less than or equal sign. In this video, we'll see how we can solve such quadratic inequalities. But first, let's look at a plot of a quadratic function, and that will help us to understand the general approach that we'll be using to solve the quadratic inequalities. So here we have a quadratic function, x squared minus 3x minus 4. And when we are looking for a solution for the quadratic equation, x squared minus 3x minus 4 equal to 0, what we are actually looking for is to look at when this function value is equal to 0. So here we can see that setting the value to 0, it means the y value equal to 0. Here, where y is equal to 0, so looking at this line, the solution to this quadratic equation here will be simply the points where the curve crosses this red line. So we have 2 points, this one and this one, and the value here is actually minus 1 and the value here is 4. So these are the solution to this equation. So x for this is minus 1 and x equal to 4. And this is what we call the roots or zeros. So now let's look at example when we have a quadratic inequality. For example, let's say that we have this inequality. Now this is similar, except that we have greater than sign instead of the equal sign. And what it means that we are looking for the value that make this function positive. If we look at again the plot that we have here, we see that the function is positive in this part. So here it is above 0, so it's positive. And similarly also at this part, it will be positive. Of course, this actually extends to infinity, and in the other side here, it goes to minus infinity. And then the middle part, this one, it's actually negative. And at the point of crossing with the red line here, at this point, this is where we have the zeros. So the solution to this quadratic inequality will be simple. By looking at the part where this is positive, we can see that this is happen if x is less than minus 1 or x is greater than 4. And similarly, if this quadratic inequality was something like less than or equal to 0, we know that it's negative on this part, but in this case also want to include when it is 0. So then our solution will be if x is greater than or equal to minus 1 and less than or equal to 4. So we're talking about this part. And notice we include also equality, so it's not just less than, it's less than or equal to 4 and greater than or equal to minus 1, because here we also considering the case when this expression is 0. Now looking at this plot, we see that identifying the 0 actually is critical to solving the quadratic inequality, because at this point the value of the quadratic function is 0, and in the region between the zeros will be either negative or positive, and the region above the second 0 and the region below the first 0 will be opposite to whatever you have here. If this is negative, then this will be positive. If this is positive, these will be negative. So let me show you a plot of another function. So this is a plot of another function. Notice that here the x squared have a minus sign, and then you look at the point where we are crossing 0, it will be here at minus 4 and it will be here at 1. And again, notice the interval between the two zeros, in this case it's positive, and the interval before the first 0 is negative, and the interval greater than the second 0 is negative. So once we identify these two zeros, then we'll be able to easily figure out what is the sign. We will just take one point in the interval and see if it is positive, that interval is positive, and so the other two will be negative. If we find this is negative, then the other two interval will be positive. So we just seen two plots for two different quadratic functions. Both of these two functions have two zeros, but one of them, the values of the function between the two zeros is negative, and the other one, the values of the function between the two zeros is positive. However, this is not the only possibility. You may have a case where the function does not touch the x-axis, so it means does not have roots. And in that case, the value of the function will be either all positive or all negative. And the third possibility is the function will touch the x-axis in one point. It means have 1, 0. And again, we have two possibilities. One where the function is all positive except 0 at one point, and the other it's all negative and 0 at one point. It will be very helpful when you are solving the quadratic inequality to visualize the general shape of the function in your head, and that will make it much easier for you to find out the solution. So what I suggest to solve quadratic inequality is first to determine the number of the roots. You can use the discriminant to get the number of roots, and then based on the number of the roots, you will have a general idea about how the plot of the quadratic function looks like. And then this will help you to find the solution, as we shall see in the examples. So let's go to the examples. Okay, so let's take the following: x squared minus 3x greater than or equal to 4. Now this is a quadratic inequality. It's a quadratic because the largest exponent for x is 2. It's an inequality because we have the greater than or equal sign. First thing that you have to do is to move all the terms to one side and leave one side to have 0. So if we move 4 to this side, then we'll have x squared minus 3x minus 4 greater than or equal to 0. What to do to solve this? First thing, as we've seen above, is that we need to identify the 0. So how to do that? We just consider the following quadratic equation. So now we are trying to solve a quadratic equation first to get the zeros. And once we identify the 0, then we'll be able to identify the different intervals. How to solve this quadratic? There are many ways. And if you want to refresh your memory about how to solve this, you can check the channel. It has several videos that describe how to do this. In this case, I'm going to use the quadratic formula to solve it. So let's first check how many roots we have. We know that we can use the discriminant to figure out how many roots it will have. Discriminant is b squared minus 4ac. B squared is the x term coefficient, so minus 3 squared minus 4a is the coefficient of the x squared, which is 1, and c is the constant coefficient, which is minus 4. In this case, it will be 9 plus minus times minus plus, and then we'll get 16, so this gives us 25. With 25, we know that we have two roots. So we have two roots. How to get the roots? Well, we use, again, there are different methods, but I'm gonna use, as I said, quadratic formula, which is minus b plus minus b squared minus 4ac over 2a. And minus b is minus 3, that give you 3, plus minus. This expression is 25. This is the one that's calculated here. So this gives us 25 over 2a. A is 1, so this gives us 2. And then we'll have 3 plus minus square root of 25 is 5 over 2. And so we'll get x. 3 plus 5 is 8. 8 divided by 2 is 4. So this gives us 4. Or 3 minus 5 minus 2 divided by 2 give us minus 1. So these are the roots. Then the critical point that we have is minus 1, and then we have 4. These are the three intervals. These are the zeros. And then we have interval between the zeros. What we need to do is to determine what's the sign for this interval, and the other two intervals will be opposite to that. So we can take any number between minus 1 and 4. In this case, I prefer usually to pick 0 because it's easy. Once you substitute 0, for example, you will get 0, and this is 0, and then you just left with minus 4. So we are looking at this function. Once you substitute 0, this will be 0, get minus 4. So it means this part will be negative, and then the other two parts will be opposite. So this is a plus and this is plus. What we are looking at here, we are looking for the ring where this expression is positive or equal to 0. When it is positive, if it is in this part or this part, but also when it equal to 0. So then our solution is x less than or equal to minus 1. Why we said less than or equal instead of less than? Because here we are also considering the case when this expression is equal to 0. Or the other interval is when x greater than or equal to 4. This actually is the same that we've seen here. See, this is minus 1 and 4. And again, you can see here it's minus. So we could figure that without plotting, just by identifying the zeros. So now let me also consider a different variation for the same problem, just to show you that once you identify the zeros, you can solve different inequalities. So if the inequality was x squared minus 3x minus 4 greater than 0, then the solution will be very simple. It's actually the same, except we are moving the equality. So we are just considering greater than. In that case, it will be similar to this solution, except that also will not have the equality. So we'll have only x less than minus 1, because we don't want the case when this expression is 0, or x is greater than 4. If we look at also another variation, what if we have x squared minus 3x minus 4 less than 0? Then again, we already identified the interval and we know it is negative in the middle interval. Then our solution will be x should be greater than minus 1 and also should be less than 4. And again, here we are looking for the interval that make this expression strictly less than 0. That's why we exclude the 0 from the solution interval. If this also includes the equality, then we again just modify this by adding the equality also in the solution. So you can see the critical part is just to identify the zeros. And once you identify the zero, just take any point in the middle interval. And based on the value of the function in that interval, you will know whether it's negative or positive. And the other two interval will be opposite. If this is negative, these are positive. This is positive. These are negative. Now let's look at another example. Again, we need to solve the quadratic equation. What's the purpose of solving this? To find the zeros. And once we find the zeros, then we'll be able to identify the different intervals. So first, let's calculate the discriminant to see how many roots we have. So this is minus 3 squared minus 4. The a is 1. And the c is 4. So this gives us 9 minus 16 or minus 7. And minus 7 less than 0 mean there are no real solution. So what to do? There is no real solution. You don't need to panic. This is actually easier than the first case. In this case, the quadratic function will be either above 0 or the other case, it will be below 0. And how to determine that is again very simple. We just look at one value for the function, and that will tell us whether this is always positive or always negative. So let's again take 0. If we take 0 and we substitute these both 0 and get 4. So this means that this expression is always positive. Always positive. Okay, so that's great, because then it means it's satisfying this inequality. We are looking at when this expression is positive, and then we find out that it's all the time positive. So then our solution is simply x. So this is any real number. Now, if this inequality actually was the other way, we have it, for example, like x plus 4 less than 0, then there is no solution. Because we know that this is always positive, but the inequality is looking for what are the values that make it negative. So there are no such value. So there is no solution for this inequality. And this will not also change if this was less than or equal, because again, there are no value that make this equal to 0. If there is any value that make it 0, it will have roots, but there is no such value. So again, there is no solution for it. And for the first case, also, it wouldn't matter whether you say greater than 0 or greater than or equal to 0. Again, the solution will be all the real number. Although there is no value to make the function 0, but we know that all the other values will make it greater than 0. So let's look at another one. So again, we start by solving the equivalent quadratic equation, which is x squared minus 2x plus 1 equals to 0. Again, let me check how many roots we will have. So b squared minus 4ac, and b in this case is minus 2 squared minus 4, a is 1 and c is 1. So this gives us 0. 0 means we have only one root. And to find it again, you can use the quadratic formula, or you can use factorization. In this case, I'm going to use factorization. So x minus 1 times x minus 1. And this means either this is 0 or this is 0. And in any case, it means x is 1. And what does this mean? It means the curve will be just touching the y equal to 0 line in only one point. And again, it means this is all positive except in one point it's 0. It's also possible you may have it looking like this. So it means it's all negative, but it is 0 at one point. How to determine whether it is positive all the time and 0 at one point, or it's all negative except at one point is 0? Again, just look at this one and just substitute any value except, of course, the root, because that will give you 0. So for example, if we select 0, this will be 0 plus 1. So it means the function, this one, positive except at x equal to 1, the root, where it is 0. So then going back to our inequality, which is, what does this inequality mean? It means we're looking for value of x that make this expression either negative or make it 0. We know that this expression is always positive, so it's not possible to make it negative. However, we can make it 0 at what point? When x equals 1. So the only solution to this is when x equal to 1. That's it, where it's equal to 0. If this was, so this is another variation. If the question was like this, then we are asked to find out what are the value of x that make this expression negative. But we know it's only positive, so there is no solution for this. And if it was something like this, then it's saying what are the value of x that make this expression positive or make it 0. But we know that this expression all the time is positive except 0 when x equals 1. So it means all real values. So x can be any real value. So x simply any real number. And that's the solution. What if this was just greater than 0? What would be the solution? So hopefully you figure it out that the solution will be all real number except x equal to 1, because x equal to 1 will make the expression 0. But here, for this case, we want only the value that make it positive. Okay, so that's it for this video.